What is science and how do scientists do it? Science is an attempt to make sense of observations made in the real world. The scientific method is used to formulate ideas and test them for their potential validity. You start with observations you make. If there is something confounding to you, then you formulate a question you can test. Based off of the question, observations made surrounding it, and any additional research conducted, you can formulate a hypothesis. This hypothesis must be easily testable, or any experiment completed following it risks being unfounded, inconclusive, or overly complicated. It is very rare that a hypothesis is 100% proven in an experiment. Usually, the data presented helps scientists further direct future experiments. It isn't a process where a scientist guesses something and then it is either completely incorrect or correct. It is more of a process of learning. Each experiment gives the scientist more information about the topic they are researching. Sometimes this is where the major discoveries come into play. It's a tinkering with previous knowledge to expand that knowledge even further. Scientists can formulate different types of results from experiments. The first is a scientific theory. This is not something that comes from just one experiment. A theory is only formed when multiple repeated experiments continuously show the same results. It is reliable and highly supported by the scientific community. A theory isn't a guess in science. It is the best explanation for phenomena that science can give. The next outcome is a scientific law. This is a statement of the observed phenomena. So remember, a law is the statement, and a theory is an explanation for why that statement is valid. Next, we will move on to systems. We will discuss systems a lot in this class, the first of which will be in Chapter 4, the ecosystem. A system is a semi-predictable set of components that interact in a semi-predictable way and can be studied in isolation. The major components of a system are the inputs, or what goes in, the flow/throughputs, or in most cases we will study the flow of matter of energy, the stores, or the accumulation of said energy and matter, and the outputs, or the waste of the system. Systems are cyclic. This means that they change based off of feedback. A feedback loop occurs when the output of a system feeds back into the system as an input and in turn changes the system. There are two types of feedback loops, positive and negative. Positive feedback loops occur when a set action in a system feeds back into the system as an input and further progresses the system in the same direction. An example would be interest on an investment. As the money invested grows, the interest increases, which in turn increases the money invested overall. It's a cycle that continues to feed back into itself. Negative feedback loops do the opposite. There is still an output that feeds back into the system as an input, but it prevents the cycle from continuing. Consider recycling here. Paper is made from tree pulp harvested through deforestation techniques. As we recycle the paper in my classroom, we are using old paper products to make new paper products, thus decreasing the amount of trees being harvested for pulp to make paper. We have effectively shut down the loop of cutting down trees by reusing the products previously made. Moving on to chemistry. As discussed in class, an atom is the smallest particle of an element that still holds the characteristic properties of said element. Atoms are broken down into three major components: negatively charged electrons, positively charged protons, and neutral neutrons, with both protons and neutrons making up the nucleus. Refer back to the bond types we discussed in class. If you don't remember what we discussed, then look back at the chemistry notes on my website. The point of explaining the bonds was so that you understand why we call water the universal solvent, and why is it even important in the first place. We will discuss not only dissolved solids suspended in solution with water, but also dissolved gases. Examples include oxygen and carbon dioxide. The mass of a solute dissolved in a water over the volume of water it is dissolved in will tell you the concentration of the solution. This will be important for quite a few labs we will be doing this first semester. Next, on to pH. pH is the concentration of hydrogen ions suspended in a solution. The more hydrogen ions and fewer hydroxide ions a solution has, the more acidic it is. Acids are characterized by sour taste, corrosiveness, and a low pH. Neutral solutions have a balance of hydrogen and hydroxide ions. They have a pH of 7. The more hydroxide ions and fewer hydrogen ions a solution has, the more basic it is. Bases are characterized by bitter taste, slipperiness, and a high pH. pH is a logarithmic equation. This means that every time you move one step up the pH scale, for instance between a pH of 3 and a pH of 4, you increase the concentration of hydroxide and decrease the concentration of hydrogen ions by a factor of 10. This also works the opposite way. 3 is 10 times more acidic than 4, 2 is 100 times more acidic than 4, and 1 is 1,000 times more acidic than 4. On to heat transfer. There are 3 types of heat transfer: radiation, conduction, and convection. The most important form for environmental science is convection. You'll see it when we discuss both water and air properties. Radiation is the transfer of energy through space, conduction through solids, and convection through fluids like liquids and gases. We will discuss energy a lot. One of the major components we will be concerned about is the quality of the energy. High-quality energy is said to not only be purer than low quality, but it can also produce more work with a given amount of energy than low-quality energy can. Low-quality energy is said to be very dilute, or it is very unuseful. Now we have a few laws to discuss. The first is the law of conservation of matter. This is fairly simple. Matter is neither created nor destroyed. It simply takes on a new form through physical and chemical processes. Next, we have the law of conservation of energy, or the first law of thermodynamics. This means that energy is neither created nor destroyed. It also simply takes on another form. The second law of thermodynamics states that as energy is transformed from one form to another, it becomes a lower quality energy, as some of the original energy is lost, typically in the form of heat. This will all relate to energy efficiency. When discussing an energy source, energy efficiency is key in making comparisons to other energy resources. The availability of an energy resource isn't the only factor to take into consideration. The efficiency, or usefulness of an energy source to create high-quality energy, is important as well. There is a lot in this chapter that I didn't cover in this video because it is information you don't need to worry about. If we need any portion of it later on, then I will cover it at that time.